7.3 and 7.4. We're moving away from multiplication and division. So 7.1 is simplified rational expression. 7.2 is how to multiply and divide. Basically, reminder, all you do is you factor out and cancel them out, right? The only thing different with division is you have to change it to multiplication and then take the reciprocal. Once you do that, everything is the same. So now 7.3 and 7.4 is where we need to add and subtract rational expression. And this is the challenge of this 7.3 and 7.4 is because you guys kind of dislike when we add and subtract fraction number or fraction, rational number, like 1/3 plus 7 over 5, something in that nature. You guys kind of dislike it. So that's why 7.3 and 7.4 is just it's the same correlation of those. It's just a different expression. Okay, so in order for us to add or subtract rational expression, the most important thing that you need to have, the one thing that you need to have in order for you to add or subtract is you need to have a common denominator. And that's where 7.3 come in. 7.3, all you need to do is identify, which in 7.3, all of your problem, the denominator is the same. Okay, so let's take a look at A. They ask you to add or subtract. So looking at this thing here, we add in this item here, 9 over x minus 3 plus x plus 1 over x minus 3. So if you look at this item, and this is your thought process, right? Whenever you see the addition, the first thing you need to ask yourself is the denominator the same? Do we have a common denominator, which in this case we do? And if we do have a common denominator, all they tell you to do with the great definition that I have up here is basically combine the top and keep the bottom, right? That's what addition, rational, or fraction is. Same common denominator, keep the denominator and add the top. So in this case, my denominator is x minus 3. I kept x minus 3. We don't take x minus 3 plus x minus 3. We will never add or subtract the denominator. All we do is we kept the denominator, which is x minus 3, combine the top, which is 9 plus x plus 1. And again, 9x plus x plus 1, which is all we do is we combine like term. And in this case, you can see that your like term is the 9 and the 1. Those are your constant. And if those are your constant, all you need to do is add them together. And that's it. That is all that is in 7.3. And you probably say, well, what is so hard about that? Well, not, right? 7.3 is not hard. We try to set you up, right? We try to set you up in terms of 7.4. So if you look at this item too, same thing go, right? Our goal or our not objection or objective, but our operation is subtraction. And in order for us to subtract, we can see that the denominator x plus 1, x plus 1. That's what you need to focus in. X plus 1, x plus 1, they are the same. And if they are the same, what do I do? Well, all I need to do is combine the top. So 3y plus 13 minus 2y. That's what the top is. That's what the numerator is. All I need to do is put the numerator together. And again, just basically insert the subtraction sign. And now what do I do? Well, as you can see, all we need to do is combine like term. And in this case, my like term, again, the denominator is the same. So I don't really need to, we don't really need to care. Well, we do need to care, but we don't really need to work or do anything with the denominator. This is all we need to do is take the numerator and combine like term. In this case, 3y minus 2y, I still have one more y left, or basically y by itself, plus 13. And there's nothing else we can do because there's nothing we can simplify, okay? So that's what we need to do in order for us to add or subtract rational expression. That's what the first thing we need to ask ourselves is, do we have a common denominator? And if we do, and in 7.3, all of your problem in 7.3, ladies and gentlemen, all of the problem in 7.3, you do have a common denominator. And if you do have a common denominator, as I told you guys, verify this item. We have this, we have check, check. And if they are the same, all we need to do is combine the denominator, combine the numerator, 3x plus 10 plus x plus 2, and cap the denominator, which is we write the denominator one time. And once we have this thing here, hopefully you guys see that my like term, what are my like term? My like term is 3x added to one more x, and 3x added to one more x. I will have 4x and 10 added to 2. Those are my constant and those are my x. So if I add them together, if I combine them together, this is what I have, 4x plus 12 all over x plus 3. So before we can say that this is our answer, right? Before we can say this is our answer, you need to ask yourself, can you simplify them? Which in chapter 7.1, they ask us to simplify, which can we, is there any way we can factor something out so that we can cancel it out? Which in this case, do you agree that 4 and 12, they have a common divider of 4? I can factor out a 4 to give me x plus 3. And again, x plus 3 on top and x plus 3 on the bottom. I can cancel them out. So my answer here is just, x, 4, right? Because everything the same on top as the same on the bottom, I can cancel this thing out. And if I cancel out, my answer is just 4, okay? So this is the idea, or this is our objective for 7.3 and 7.4. Let me ask you guys any question here in terms of how your problem should look like or in 7.3, and what do you guys need to do in order to simplify or combine this item and simplify them if you can simplify. So question with A, B, or C. All right. If you don't have question with A, B, or C, let's take a look at D, right? And again, looking at this thing here, first of all, I want to point out to you guys, I know this look massive. I know it's look massive, it's look confusing, but go with your thought process. The first thing we recognize, or the first thing you see that we know that is a subtraction problem. And if it's a subtraction problem, now we know that in order for us to add or subtract, my denominator have to be the same. So do you agree, looking at this thing here, the denominator are exactly the same. We have x squared plus 4x minus 32. X squared plus 4x minus 32 is the same. So yes, you can factor them out if you want to, but for now, just if they are the same, life is good, right? If they are the same, this is all we need to do is we say, okay, I have the same common denominator. Now, all I need to do is combine the numerator. So if you look at this thing here, the reason why I put the parenthesis here, because I have two terms. You say, why I did not put the parenthesis? Why didn't I put the parenthesis here? Because it's only 2y. There's no other term. I don't really need to have a parenthesis. The reason I have two terms here, I need to put the parenthesis because I have to distributive the negative in. Because of this minus sign, I have to distribute this item in terms of I need to change the sign of the 2x and change the sign of the 3. So all I did was I distributed this item. I distributed this negative in to become a negative 2x, and a negative become a positive. And once you have that, what do? Well, all we need to do is once we distributive the negative, we combine like term. And what are the like term? Well, 3x take away 2x. And 3x take away 2x, everybody see that I still have 1x left. 3 minus 2, I have 1x, or simply just an x. And negative 7 plus 3, well, negative 7 plus 3, same sign I add, opposite side I subtract. And again, if I subtract, I kept the sign of the larger number. So negative 7 and a positive 3, I need to subtract to give me 4. The bigger number is a negative, so I have to keep a negative 4. So everybody see that on the numerator, once I combine like term, this is what I have, which is x minus 4. And again, all we did was, because the denominator is the same, I combine the numerator. And if I combine the numerator, because there are multiple terms in the second item, I don't need the parenthesis here. You say, wait a minute, Mr. Tran, why don't you put the parenthesis here? I don't have to. The reason is addition does not change anything, right? The addition time addition is still addition, addition time subtraction is still subtraction. So we don't need to change the sign. That's why there's no need to have a parenthesis. The reason is because it's a subtraction, and because of a subtraction, we need to have that, or you guys want to have that parenthesis. And if you want to, you can put the parenthesis here. It doesn't change anything. Just realize that this one here, I need to distributive, I need to change the sign for both of the second term and not just the 2. I need to change the sign for the 3 too. Okay. And once we have this thing here, before we can declare that this is our answer, the last thing we need to ask ourselves is, is there any way we can cancel this thing out? And again, to be safe, what you want to do is you want to ask yourself, can you factor anything out, right? So before we move to the next problem, hopefully you guys see by now that we can factor this item out. Why? Because is there 2 numbers multiplied to give you 32, but subtract to give you 4, positive 4. And hopefully you guys already saw ahead of me and say 8 times 4, and 8 times 4 is 32, and 8 minus 4 is 4. And because of the 4 is positive, the 8, the bigger number, have to be positive. And as the same as 7.1, x minus 4 on top and x minus 4 on the bottom, they are exactly the same. I can cancel them out. So the remainder, or what left over, the leftover is x plus 8 on the denominator. And because it's on the denominator and I need to illustrate that it's on the denominator, I need to put the 1 on top. Okay, so I cannot just put x plus 8 because x plus 8 by itself is a whole number. So I need to put the 1 to illustrate that x plus 8 is on the denominator. Okay, so let me ask you guys a question here with the process, or question here with the item we have here. Question with A, B, C, or eventually D. So can you guys handle this kind of problem? Hopefully, right? Hopefully you guys can handle it. So let's move to 7.4. And we will get to do 7.3 again, because in order for you to do 7.4, you need to know 7.3. And 7.3, all of the 7.3 material, you have a common denominator. Okay. Now, what happens if you don't have a common denominator? What happens if you don't have the same item? So we begin with ask you, if we have this 2 number, we don't care about the numerator, we only care about the denominator. And as you can see clearly, the 8 and the 9, they are not the same. And if they are not the same, what do? we need to find the LCD, which is the least common denominator, which is one number that both the 8 and the 9 can go into. And I want to show you a small shortcut. This thing will help you a little bit, along the way or later on. The easiest way to find the common denominator, is basically take the two denominator and multiply them together. Okay, that's the easiest way to find the common denominator. It might not be the least. In this case, it's the least, but it might not be the least, but it's the common denominator. All you need to do to find the LCD for this one here, you just take the two denominator and multiply them together. Okay, so most of the time when two numbers are consecutive, this is the least common denominator too. If they have nothing, if they don't have a common divider, that's what you can do. The other thing is, if you want to find you can multiply them and then divide what they have in common. If you want to do that. For instance, if you have a 3 and a 9 as your denominator, and you don't see that 9 is the least common denominator, you can basically multiply the 3 times the 9, and what does the 3 and 9 have in common in terms of the common divider? The common divider is 3. So again, 27 divided by 3, you see that the LCD is 9. Okay, but again, this is one way to do it to find a common denominator, is take the two denominator and multiply them together. The reason why I show you this, or the reason why I give you this problem is, for instance, if you have something like this, and they ask you to find the LCD, okay? If they ask you to find the LCD, if you look at this thing here, clearly they are different. One of them we have 4x squared, the other one we have x minus 5. Yes, I don't care about the numerator. Again, if they ask you to find the LCD, we don't care about the numerator. The numerator can be whatever they want it to be. All they ask you to do is, how can you make your denominator to be the same? Or what is the least common denominator? And looking at this item here, this is the idea, is if they are different like this, to find the LCD, the easiest way to do is take the two numbers, 4x squared, multiply with x minus 5, or basically put them together. Okay, you don't have to multiply them. You don't have to distribute them in. You can just identify 4x squared and open parenthesis x minus 5. You don't have to give me 4x to the third minus 20x squared. You don't have to distribute this thing here. All you do is you take the two denominator and you put them together. That's it, ladies and gentlemen. Okay. Same idea go. Doesn't matter what the numerator is. The numerator can be whatever they want it to be. We don't care yet. For now, we don't care, right? All we care about is what is the denominator, and how can we make the two denominator become an LCD? Okay, that's our goal. That's our objective. How can we find an LCD? So to find an LCD, this is all you need to do, is one of them is x plus 7, the other one is x minus 2. So all you need to do is put them together. And if you put them together, this will be your LCD. Okay. So again, the easiest way to find the LCD is take the two denominator and multiply them or put them together. So question here in terms of how to find the LCD. Question with the LCD here. This is your LCD, x plus 7, x minus 2. The other one, the LCD is 4x squared, x minus 5. And again, the LCD is 9 and 8. But again, because it's the constant, because they have a constant, so 9 times 8 is 72. And let's see what happened if they have something like this. What happened if they have something like this? If you look at this item here, you say, wait a minute, Mr. Tran, can I just take the two item? And just put them together, right? can I just take this item here, x squared minus 4 and x squared minus x minus 6, and put them together? You could, but that's not what they want, okay? Because like I mentioned to you guys, if we have something like this, if we have something like, let's say 12 and let's see, 12 and 18, right? 12 and 18, if you take the 12 times the 18, you will get 6, 2, 3, 6, 8, 1, 216, is that correct? If you take the 12, if you take the 12 times the 18, you have 216, right? So 216 is a common denominator, but it's not the least common denominator, because like I mentioned to you guys, between the 12 and the 18, do they have something in common, right? Do they have a common divider? In this case, they have a 6 as a common divider, right? So if you want to find the LCD, you can see that 216 divided by 6, this thing will give you 36. And 36, that is your LCD. That is your least common divider. Because again, 12 can go to 36 3 times, and 18 can go to 36 2 times, right? So I mentioned earlier is if you want, the LCD is the smallest number that both of them can go into. The 12 can go into it and the 16 can go into it, okay? So in the sense that if you take the two number, I told you that yes, you can find a common divider and then you can reduce at the end, or in this case, you can divide it by a common divider and to find the LCD, okay? So between the 18 and the 12, the LCD is 36, okay? That's your LCD, that's your least common denominator. 216 is a common divider, but it's not the least, it's not the smallest, okay? So looking at that, if you take the x squared, I cannot type x squared with this item. If you take x squared minus 4 and put that together with x squared minus x minus 6, it's a common denominator, but it's not the least one, okay? So what do we do here? Well, we need to ask ourselves, can we factor this thing out? Because clearly looking at this thing here, I don't know what their common divider is. I don't know what they have in common, right? I don't know what they have in common. If I just looking at this item here, clearly it's not an x because this is a binomial and this is a trinomial. So x squared is not the common term, okay? In order for us to know the common term, this is what you guys need to do, is you need to ask yourself, well, can I factor x squared? Can I factor x squared minus 4? Do you agree that x squared minus 4 is a binomial and is a perfect square? Which do you agree that x squared minus 4, I can factor out x plus 2, x minus 2. And now, can I factor x squared minus x minus 6? Again, x squared minus x minus 6, do you agree that this thing here, is there two numbers multiplied to give you 6 but subtract to give you 1? And again, hopefully you guys say that 3 and 2, right? X minus 3 and x minus 2, okay? So this is the factor of the first item, x squared minus 4, which is x plus 2, x minus 2. And this is the factor of the second item, x minus 3, x plus 3, okay? So the first thing is, because we have an x squared, we have to have an idea that we need to factor. And if you look at this item here, if you were to do the same thing that I mentioned to you guys earlier, is if you put them together, everybody see, if you put them together, this is what you have. You have x minus 2, x plus 2, x minus 3, x plus 2. If you put them together, everybody see that we have those 4 items. But remember, if we just put them together, they are a common denominator, but they are not the least. How do we get the least? Well, what do they have in common? What do they have in common? Do you agree that they have, up here we have an x plus 2, down here we have an x plus 2, meaning we have to throw away one of the x plus 2, meaning this item have to, what they have in common, we cannot use it twice. So in the sense of this thing here, your LCD, to be short, your LCD is you put them together, but if they repeat it on both items, we only use it one time. Whatever they repeat it, we only use it one time. So again, to find the LCD, given this problem, to find the LCD, we need to factor them out. And as a solve, we put everything together. Whatever the factor is, we put them together. But if they happen to repeat it, we only use it one time. We cannot use the double x plus 2 up here and x plus 2 up here and x plus 2 down here. Okay, so again, this is, treat this as one problem, one square, and treat this at the other square. So between the two square, what is your factor? You have x minus 2, x plus 2, x minus 3, x plus 3. So all you need to do is put this item together. And if they happen to repeat it, we only use it one time. Okay. So again, I know you guys have a little question. Let's take a look at another problem. And then hopefully the second problem clear it out a little bit. So looking at this thing here, once again, we don't worry about the numerator. The numerator, we don't really care because they ask us to find the LCD. So to find the LCD, unlike A, B, and C, we cannot just take the two and put them together. So what do we need to do? The first thing we need to do is we need to factor them out to make sure if they have something in common. If they don't have anything in common, yes, you just put them together and call it a day. But if they do have something in common, we put them together, but whatever in common, we cannot duplicate it. We cannot reuse it. We only use it one time. Okay, so let's factor this thing out. We have x squared minus 6x plus 9. Is there two numbers multiplied to give me 9, but add together to give me 6? And hopefully you guys say, yes, there is a 3 times 3, right? 3 times 3 is 9, and 3 plus 3 is 6. So we know that 3 times 3, and again, because it's addition, they have to have the same sign. So both of them will be negative. Negative 3 times negative 3 will give me a positive 9, and negative 3 and negative 3, when you add them together to give you a negative 6, right? So we factor that, we're done. We got the first factor. Now we need to factor the second one. Is there two numbers multiplied to give you 24, but add together to give you 11? And it's not 4 and 6, ladies and gentlemen, because 4 times 6 is 24, but 4 plus 6 is 10. And it's not 12 and 2, right? 12 times 2 is 24, but 12 plus 2 is 14. So the other thing you should, have an idea that if this thing is 3, maybe, just maybe, the multiple of 24 have a 3 in it. And hopefully you already saw, or some of you already see it. 8 times 3 is 24. Negative 8 times negative 3 is positive 24. Negative 8 plus a negative 3 is a negative 11. So we factor out the second item. So we factor out this item here. So everybody see that we have this. So again, one thing is, do you agree that they are repeated one time? This thing here, we have x plus 3, x plus 3. Down here, we have x plus 3. So this item repeated one time. They repeated one time. So again, when you're using this item, here, they don't let me use. When you're using this item, when you put them together, basically because they repeated once, we use it only one time. We don't duplicate them, okay? So we know that this is what we need to do. We need to include this item, and we need to include this item, right? And we need to include just one of this, not double them. Okay, so once we have this, all we need to do is put them together. We need to use the x minus 3, x minus 3, and x minus 9. So your LCD, we do not use the x minus 3 for this one here. So I know you say, wait, why are we using x minus 3, x minus 3? Remember, this is the 2 box. If they repeat in the same box, we gotta use it. Okay, if they repeat it in a different box, we use it one time. Okay, basically whatever in the different box, as you can see right here, the 2 box I have is x minus 2, x plus 2, and x minus 3, x plus 2. Because they repeat it, I still using it. I still using x minus 2. We don't just throw it away. We still use it, but we only use it one time. Okay, so that's the idea of this LCD here. To find the LCD with this kind of problem, the first thing we need to do is we need to factor them out. And then once you factor them out, you put the factor together. If they repeat it at a different location, if they repeat it at a different location, we use it only one time and not double. Okay, so again, let me pause for a bit. Let me ask you guys a question here. Let me ask you guys any question here. Question of how to find the LCD. Because ladies and gentlemen, that is the first step to 7.4. Let's take a look at 7.4. So 7.4, this is why we mention about LCD. If you're looking at 7.4, this is where the problem come in, is we add them, but they don't have a like tone. So as you can see, this one here, we have 3 over x plus 7 over y. Clearly, right? Clearly at day, the 2 denominator are not the same, right? We don't have a same common denominator, so we don't have a check. Remember, I told you that in order for you to add or to subtract, we need to have a same common denominator. And this is 7.4. We don't have a common denominator. So if we don't have a common denominator, what do we do? Well, if you look at this item here, I give you guys the steps over here. The first step is you want to find your LCD. And remember, to find your LCD, all you need to do is take your denominator, put them together. If they repeat it on a different location, we only use it. We still use it, but we only use it one time. Okay. And now the second item we have to do is now we will deal with the numerator. Rewrite your expression as an equivalent fraction whom denominator is your LCD. Meaning now we changing the denominator to the new LCD. And because we change in the denominator, we need to change the numerator. Basically, in short, all you do is you insert a missing value from your LCD to the numerator and the denominator. And once you have that, you add the numerator and kept the denominator, and then simplify if possible. It will be very hard to simplify this kind of problem, but they might. So looking at this thing here, let me ask you, what is your LCD? Do you agree that your LCD is you just take the X, put it together with the Y? We don't have any repeated. My LCD is I took my X and put it together with my Y. My LCD is X and Y, X times Y. That's the first item, is take the two items. If you cannot factor them out, just take the two items and put them together. If they happen to repeat it, we put them together, but we're using the repeated item one time. So once you find the LCD, this is the second step. Is all we need to do is insert what you're missing from your LCD. Do you agree that 3x, what am I missing from the LCD? I'm missing a y. So if I'm missing a y, all I need to do is put the y on the numerator and the y on the denominator. And on the 7y, 7 over y, what am I missing from my LCD? You can see that clearly we're missing an x. So again, if I'm missing an x, I put the x on the numerator and the x on the denominator. Do not, ladies and gentlemen, for 7.3 and 7.4, do not cancel in the process. Do not cancel in the process. You only cancel at the end of the problem, okay? So looking at this thing here, because if you cancel the y and the y and x, you eventually go back to your original problem, okay? So now, do you agree? Ladies and gentlemen, do you agree that my denominator xy, my denominator xy is the same? Do you agree that yes? Now, do you see that we have a common denominator, right? xy, that is my common denominator. And if that's the common denominator, what do we do? Well, life is good. Why? How good is this? All you need to do is combine the numerator and cap the denominator. So once we identify that the denominator is the same, we go back to 7.3, and 7.3 tell me whatever my numerator is, I put it together and cap one of the denominator. So in this case, everybody see that 3y plus 7x, 3y plus 7x is on the numerator, and the denominator is just xy. And there's nothing else you can do. There's nothing else you can cancel out. There's nothing else you can, no, there's nothing else to do here to simplify. This is your answer. Remember, we cannot take the y cancel out and the x cancel out because on the numerator, in the numerator is a binomial. And in order to cancel out the binomial, you need to have the exactly same binomial for you to cancel out. If you don't have a same binomial, this is your answer, okay? So let's try one more. I know you guys kind of a little bit iffy. Let's try one more and then see if your answer, see if is answer your question. So if you take a look at this thing here, same thing go, right? Your thought process is we have a subtraction. My denominator is not the same. My denominator is not the same. In this right here, I have an x, and in this over here, I have an x plus 5. Clearly, they are not the same. And if they are not the same, you cannot add them, you cannot subtract them. You can only multiply, but this operation is a subtraction. So we cannot do anything yet until our denominator is the same. I see that. So how do we make the denominator to be the same? Well, to make the denominator the same, we need to find the LCD. The LCD is they basically tell you take the first denominator and put it together with the second denominator. And that's what your LCD is, which is your LCD is x plus 5. All you do is you take the first denominator, put it together with the second denominator, and if they happen to repeat, then you use it one time. But in this case, this is not repeat. One of them is a monomial, the other one is a binomial. So again, they are not repeated. So this is what we have, the LCD. So once you find the LCD, this is what you ask yourself. In the first item, what am I missing from the LCD? In the first one here, everybody see my first item, I have 2x. That's what I have, 2x. What am I missing from the LCD? Well, if I already have an x, do you agree that I'm missing the x plus 5? So if I'm missing x plus 5, all I do is I put an x plus 5 on the numerator and an x plus 5 on the denominator. And now in the second item, I have 5 over x, I mean not 5, 8 over x plus 5. What am I missing? Do you see that I'm missing just a plain old x? I'm missing just an x because my LCD is x plus 5. This is my LCD. And to find my LCD, I need to take the first item, the first denominator, and put it together with the second denominator. And again, once I find my LCD, basically all I do is I want my denominator to look like my LCD. So just disregard the red ink. We have x plus 5, x plus 5. My denominator is look like my LCD. And again, if you change your denominator, and we totally did, right? We changed the x and we changed the x plus 5 to become this item. So if you change your denominator, you have to change your numerator. And again, basically, whatever you put on the denominator, you have to put on the numerator. And once you have this, everybody see, this is our goal, ladies and gentlemen. This is our objective. My denominator is the same. And my denominator is the same. All we need to do is cap the denominator and combine the numerator. So again, this is what I have. My numerator, I have 2 open parentheses, x plus 5 minus 8x. The denominator is the same. And once I have this thing here, everybody see that I need to distribute the 2 in. 2 times x is 2, 2 times 5 is 10, minus 8. What is 2 minus 8? Do you agree that 2 minus 8, a smaller number minus the bigger number, to give me a negative? So I have negative 6x plus 10. And this can be your answer. And some of you guys say, well, Mr. Tran, can I take out a 2? You could take out a 2, but you still cannot cancel anything out, right? You can take out a negative 2. This thing is a negative, guys. If you take out a negative 2, this item right here is not a positive 5, but it's a negative 5. Okay. Apologize for the error. This back here is negative 5. So if you take out a negative 2, because negative 2 times 3 will give me negative 6, and negative 2 times a negative 5 will give me a positive 10. Even if you take out negative 2, there's nothing you can cancel out. So basically, this can be your answer, or this can be your answer here. Because even though you take it out, there's nothing you can cancel them out. Okay. And again, let me ask you guys a question here in terms of the step or the procedure. How can we get to this answer? Any question here, ladies and gentlemen? Well, if you cannot come up with a question, let's take a look at another problem, right? Let's take a look at another problem. If you have a question and you don't know how to structure your question, let's take a look at another problem and see if it's clear or more confusing. Hopefully clear. Let's take a look at this problem C. Someone have a question? Lost. Okay. Well, let's take a look at this problem and then see. Like I say, 7.4. 7.4 probably the hardest one of all. 7.4 probably the hardest item because of the steps and the procedure. So first of all, let's say if you have this question on your homework, on your quiz, on your test, right? What do we do? Well, first of all, we cannot just one thing we cannot do, ladies and gentlemen, one thing we cannot do is this. We cannot say 2 minus 5, and then on the bottom is will be x plus 3 minus x minus 12. That is a big no-no, okay? So one thing is we cannot do that. We cannot just subtract the top and subtract the bottom and we call it a day. So first of all, everybody recognize that in order for you to add or subtract, you need to have a common denominator, meaning this item right here have to be exactly the same, okay? That's the first thing you want to ask yourself is the denominator the same? If last time in 7.3, right? In 7.3, my problem was this. My problem was something like this. 2 over, let's say, x minus x plus 3 and 5, let me do this, subtract 5 over x plus 3. So if you remember in chapter, in chapter 7.3, this is what we have, right? We have something in this nature. We have 5 over x plus 3 minus, 2 over x plus 3 minus 5 over x plus 3. And we say, well, x plus 3 and x plus 3, they are the same. And if they're the same, I just subtract the top and kept the bottom. My answer would be -3 over x plus 3, okay? But we don't have that for this particular problem. Clearly, we can see that x plus 3 and x minus 12, they are different. And if they are different, our goal is we need to somehow make that, change that to be the same. And to make that or change that, to make it the same, we need to find the LCD. And the LCD is basically, all you do is you take the two denominator and you put them together. That's it. You have x plus 3 on one side, x minus 12 on the other side. All you do is you take the two denominator and put them together, smash them together, or basically multiply them. But you don't need to multiply them. You don't need to distribute them. You just put them together. So my LCD is x plus 3, x minus 12. Now, what do I do with the LCD? Meaning now, this is what you have, ladies and gentlemen. Let me block this item here. This is what you have is, your goal is this. The reason why we do the LCD is we want the denominator to be the same. And in this case, x plus 3, x minus 12, that's my LCD. X plus 3, x minus 12, that's my LCD. So everybody see that our goal is we want to have the denominator to be exactly the same. And to do that, all I do is I change my denominator to become an LCD. And how do I get the LCD? I take the two denominator from the original problem and put them together. Everybody still with me here? Our objective is we have to have a common denominator. And to have a common denominator, we need to have the LCD. And to have an LCD, I take the two original denominator and put them together. Now, once you have that, now you have to go back and ask yourself, well, clearly we changed something, right? This up here is my original item. My original item is 2 over x plus 3. But now my denominator have a Lagrange x plus 12, x minus 12. How did I do that? Well, if I insert the x minus 12 on the denominator, I need to be fair and insert the x minus 12 on the numerator. And basically that's what we have. What are you missing from your LCD? Well, I'm missing x minus 12. Let me put x minus 12 on the bottom and let me put x minus 12 top. Same thing go over here. What am I missing for my LCD? Or how did how did you change from 5 over x minus 12 to become x plus 3 x minus 12? Well, do you believe that all we did was we insert the x plus 3? And if I insert x plus 3 on the bottom, I need to insert the x plus 3 on top, right? That's what I need to do is how can I convert this item to look like my LCD? And whatever I converted, whatever I insert them in, I need to insert the numerator and also insert on the denominator. And now our goal have met. Our ultimate goal have not met, but our kind of semi-goal is met. Why? Because my denominator is the same. My denominator is the same. So what do? All I need to do is combine the numerator. Whatever my numerator is, I put it together and I kept the denominator. And that is our semi-goal, right? My semi-goal is I want to combine them together. And in order for me to combine them together, I need to have a same common denominator. Everybody still with me here? Again, our ultimate goal have not done, right? Our ultimate goal is we need to combine the numerator too, but our semi is we need to put them together. And now the only thing different now is we need to distribute the 2 in. And if I distribute the 2 in, I have 2 times x will give me 2x. 2 times negative 12 will give me negative 24. And I need to distribute the negative 5 in, which is negative 5 times x will give me negative 5x. Negative 5 times 3 will give me negative 15. And once I have that, all we need to do is combine like term. And if I combine like term, everybody see that 2x, my like term are 2x minus 5x. And a 2 minus 5, that will give me negative 3x, because a smaller number subtract the bigger number. So that's what my negative come from. And my other item, I have negative 24 and a negative 15. They have the same sign, and negative, I need to combine them to give me a negative 39. So again, all of this thing here, this is why I have 2 minus 5 to give me negative 3x, negative 24 and negative 15 to give me a negative 39. And yes, you can take out a negative 3 because 3 can go into this, but there's nothing to cancel them out. So you don't really need to factor them out. So this is, you can give me this answer or you can give me this answer here. Okay. So again, this is the answer we're looking for. Either this item and or this item if you want to factor the item out. Sometime when you factor them out, they they can cancel something out, but they have to try very, very hard. This problem here, if I make it up on the fly, it will be very hard to factor something out so that they can cancel out. Most of the time you can't. But question here in terms of the step, in terms of the procedure here. Any question here, ladies and gentlemen? I think I have another problem. And I think I have another problem after this, but if you don't have question, let's advance to a little bit. Last time, if you look at this problem, it's easy to see that we have x plus 3, x minus 12. They are clearly different, right? But if you look at D, first of all, you can see that x minus 6, x plus 9, x plus 5, x plus 9, they are different. You have to recognize that that is different, right? So if they are different, we cannot just take, if this were to be x plus 9, then all you have to do is take 6 plus 7 13 over x plus 5, x plus 9. But clearly they are different. And if they are different, we cannot just combine them and call it a day, right? Where they are different. So now if they are different, this is what we need to do is we need to find a LCD. How do we find an LCD? This is what you need to do is you need to take the first item, x minus 6, x plus 9. Put that together with x plus 5, x plus 9. All you do is you merge them together. But if they repeat it on both sides, then we only use it one time. Okay, that's what the rule is. If they repeat it on both sides, all you need to do is use it one time, meaning the x plus 9 is on this side and the x plus 9 is on the other side. So all I need to do is use the x plus 9 only one time. I don't need to use it twice because they repeat it on both sides. Okay. Last time, if you say, wait a minute, Mr. Tran, the previous one, yes, the previous one, we don't have anything repeated, right? The previous one, this is what we have, is we only have x plus 3, x minus 12. We just merge them together, x plus 3, x minus 12. But now, this problem, they have something repeated. And if they repeat it, we only use it one time. So my LCD, ladies and gentlemen, my LCD is x minus 6, x plus 9, x plus 5. That is your LCD. What do we do with the LCD? This is what we need to do is we ask ourselves, right? Let me do it this way. This is our goal. Our goal is once we find the LCD, meaning my denominator is my LCD. So whatever my LCD is, I just put on the denominator. That's the goal to find the LCD is your denominator is your new LCD now. Why? Because they are exactly the same. X plus 6, x plus 9, x plus 5 on one side, x minus 6, x plus 9, x plus 5 on the other side. They are exactly the same. We have met our criteria, meaning my item, my denominator is the same. Now, if they are the same, all I need to do is combine the numerator, okay? But before we do that, we change something, right? We change something. What did we change? How did we make x minus 6, x plus 9 to become x minus 6, x plus 9, x plus 5? Well, all we did was we insert the x plus 5. And if we insert the x plus 5 on the denominator, we need to be fair and insert the x plus 5 on the numerator. Same thing go. How did you change x plus 5, x plus 9 to become x minus 6, x plus 9, x plus 5? Again, all we did was we insert the x minus 6. And if we insert the x minus 6 on the numerator or on the denominator, we need to insert on the numerator. And that's our goal, right? Our goal is we need to have a common denominator. And if we have a common denominator, all we need to do is combine the numerator and cap the denominator. My denominator is x minus 6, x plus 9, x plus 5. Or if you want to write x minus 6, x plus 5, x plus 9, it doesn't matter what the order is, that is your denominator. Now, what do I do with the numerator? Well, I need to distribute the 6 in, which 6 times x is 6x. 6 times 5 is 30. I need to distribute my 7 in, which is 7 times x is 7x. And 7 times a negative 6 will give me a negative 42. Now I need to combine like term, which is the 7x and the 6x. That will give me 13x. And a 30 minus the 42 will give me a negative 12. 13 and negative 12, we cannot reduce them. We cannot factor anything out, and that or this is your answer. And like I say, most of this question here, you cannot you cannot cancel them out. We have to try very hard to fix it, to fix it so that you can cancel them something out. But again, question here, ladies and gentlemen, any question here? Have you found the question, or have you found how to structure your question? All right, let's do, I think I have one more. Let's do one more. This is your ultimate problem. Your ultimate item is something like this. And let's do this one more here, and then we see if you can figure it out, or if you have question. And we can do this more of this tomorrow if needed. But looking at this item, same thing go, right? Same thing go. Clearly, they are not the same. Clearly, x squared plus 7x plus 6 is not the same as x squared plus 3x minus 18. So for now, before we can do anything, just ask yourself, I cannot just put them together, because if I put them together, it will be kind of a mess, right? Because of the x squared and stuff like that. Your goal is you want to get it somewhere to be like this. Get it somewhere to be like this item right here. Where you have the first parenthesis, second parenthesis, first parenthesis, second parenthesis, where you have some parenthesis like this, okay? That's your, so if you look at this problem here, we don't have that parenthesis, but we can have that parenthesis, which in this case, hopefully you guys can see that we can factor out the first item. Is that two numbers multiplied to give you 6, but add together to give you 7, which is again 6 times 1 will give you 6. 6 plus 1 will give you 7. So again, we factor this thing out, which is x plus 6, x plus 1. And in the second item, is that two numbers multiplied to give you a negative 18, but subtract to give you 3. Well, we know that x plus 6, x times 3, because 3 times 6 is 18, and 6 minus 3 will give me 3. So this is our item, or in terms of this thing here, my LCD is I put them together. It's just that the x plus 6 repeated. I only use it one time. Okay, that's what we have in terms that my answer, or not my answer, my LCD is x plus 6, x plus 1, x minus 3. And how, or what am I missing, right? This is what we have is the numerator x plus 7, x squared plus 7x plus 6. The factor is x plus 6, x plus 1. What am I missing from the LCD? Well, I'm missing the x minus 3. So I put the x minus 3 on top and x minus 3 on the bottom. In the second one, when I factor out, I have x plus 6, x minus 3. What am I missing? Well, I'm missing x plus 1. And again, I need to put the x plus 1 on top and x plus 1 on the bottom. And like I mentioned, we got it, ladies and gentlemen. My denominator or your denominator are the same. And in this case, what we need to do, we need to combine the numerator. And if we combine the numerator, this is what we have. 2x times x minus 3 minus 5x times plus 5 times x plus 1. So basically now my new problem is this. We don't care anything prior to that. This is our new problem. And hopefully you guys see that the denominator, we don't need to do anything with the denominator. Once you factor out, once you got the GCF, you just kept the GCF, LCD, I'm sorry, not GCF, the LCD as before. Now, what do I do? Well, to combine this thing here, do you agree that I need to distributive the 2x in? And if I distributive the 2x in, I have 2x times, 2x times x will give me 2x squared. 2x times a negative 3 to give me a negative 6x, right? If I just focus on this thing here, this is what I have is I distributive the 2 in for the x. So 2x times x is 2x squared, 2x times 6 to give me negative 6x. And again, negative 5 times x will give me negative 5x, and negative 5 times 1 to give me negative 5. My denominator is the same. So all I did was I just rewrite my denominator. I don't need to multiply. I don't need to do anything. Once you establish your denominator, your LCD, that will keep on carry on down. So now what do I need to do? Well, I need to combine like term. And if you combine like term, this is what you have is the x squared, or not x squared, 2x squared, negative 6 and a negative 5, that will give you a negative 11. Negative 11. So again, this is what we have. Again, let me block the denominator. And looking at this item here, we cannot factor this thing out. I know you want to try to factor it out, but you cannot, because the 2 times the 5 will give you negative 10, and there's no number multiplied to give you negative 10, but subtract to give you 11. So once we have this thing here, we cannot factor them out. This will be my answer. And even if you factor them out, you probably won't be able to cancel them out. But again, this is the idea of this item here. This is what we need to do, in the sense of adding or subtracting with unlike denominator. Okay. Question here, ladies and gentlemen. Well, I think I have one more. Let me ask you guys to try this one. Let me ask you to try this one here at home. We will pick up on this one tomorrow. We will do a few more problems, and then if we have time,